let's talk about a piece of engineering that's so common, so fundamental, you probably use it every single day and have no idea. We're talking about the flywheel. It's truly one of the unsung heroes of the mechanical world, and it's all about keeping things running smoothly. So let's get into it. So think about this for a second. The engine in your car, it works by creating thousands of tiny, incredibly violent explosions every single minute. I mean, that's just what it is. So how on earth does that chaotic, jerky process give you the smooth, steady power you need to just cruise down the highway?
Well, the secret is hiding in plain sight. You see it right there bolted to the end of the engine's crankshaft. It's that big, heavy metal disc. That simple-looking part is the key. It's what tames all that chaos happening inside the engine.
And that disc has a name, of course. It's the flywheel. And really, it's one of the most elegant solutions you'll find in engineering. It solves this huge problem of uneven power by basically acting like a mechanical battery. Here's a nice, clean look at one. At its core, it's just a heavy wheel, but it's designed to have a large moment of inertia, which is just a fancy way of saying it really, really does not like to change its speed. Once you get it spinning, it wants to stay spinning. Its job isn't to make power, but to manage it, to store it up and then let it go at just the right moment. You know, this battery analogy is just perfect. If an engine's power stroke is like a sudden jolt of electricity, the flywheel is like a power bank. It soaks up that jolt and then trickles the energy out in a nice, smooth, continuous stream. It totally bridges the gaps when the engine isn't actively making power. And if you want the textbook definition, here it is. A flywheel is an energy reservoir. It's such a simple, beautiful idea, right? When you've got extra energy, you put it in the bank, the flywheel. When you're running low, you make a withdrawal. That's it. So here's the play-by-play. When the engine fires, that burst of power makes the flywheel speed up a little, storing that energy as rotational motion. Then, during the other parts of the cycle where the engine is just coasting, the flywheel's own momentum keeps everything turning, giving that energy back and slowing down just a tiny bit. Now, it doesn't make the speed perfectly constant, but it turns a wild up and down ride into a much, much gentler wave. Okay, so let's zero in on the flywheel's most famous job, taming the internal combustion engine. This is really where it became a superstar. See, here's the problem in a nutshell. A typical four-stroke engine. You've got intake, compression, power, and exhaust. Only one of those, the power stroke, actually makes any energy. The other three are actually using energy just to happen. So without a flywheel, the engine would just lurch forward and then immediately stop. Every single time. It just wouldn't work. And this, right here, shows you the problem and the solution perfectly. On the left, that jagged graph, that's the engine's power delivery. You've got these huge spikes of energy and then nothing, just valleys. It's a mess. And on the right, there's our hero, the flywheel, bolted on and ready to soak up those spikes and use that energy to fill in the valleys. Engineers actually have a way to measure this jerkiness. It's called the coefficient of fluctuation of speed. It's just a number that tells you how much the speed wobbles up and down. A big number means a rough ride. A really, really small number means it's running silky smooth. And the whole point of designing a flywheel is to get that number down to exactly where you need it for a particular machine. And check out this table because it tells a really interesting story. A big rock crusher, it can be pretty jerky. A fluctuation of 0.2 is totally fine. No one minds. But look all the way down at electrical machines, like a power generator. They need unbelievably stable speed to make clean electricity. So they need a flywheel that gets that number down to 0.003. The engineering needs are just worlds apart. But wait, there's more. Flywheels aren't just about smoothing things out. They're also the secret weapon for machines that need a huge, sudden burst of power. Yeah, I'm talking about the heavy hitters of the industrial world. Things like giant punch presses that stamp out metal parts, or huge shears that slice through steel, or even those riveting machines. These things do all their work in the blink of an eye and with incredible force. So the challenge here is totally different. It's about delivering a knockout punch. Imagine trying to power a giant punch press with just an electric motor. To get that split second of immense power, the motor would have to be absolutely enormous. And it would just sit there doing nothing 99% of the time. Talk about inefficient. And this is where the flywheel is just pure genius. You use a much smaller, way more efficient motor. But it's not powering the punch directly. Nope. Its only job is to run all the time, steadily spinning that big, heavy flywheel up to speed. It's just pouring energy into it, second after second. Then, when it's time to act, bam, you engage a clutch, and all that stored up rotational energy gets dumped in one massive, powerful burst. It's how you let a little motor do the work of a giant. So let's kind of pull back and look at the big picture here. The real impact of this simple spinning disc is, well, it's huge. It's so much more than just a heavy piece of metal. And hey, one quick thing, it's really important not to mix up a flywheel with something called a governor. They sound similar, but they do totally different jobs. The flywheel smooths out the little jitters from one moment to the next within a single rotation. The governor, on the other hand, looks at the engine's average speed over time and adjusts the fuel when the overall load changes, like when your car starts climbing a hill. So one's an energy buffer, the other's a cruise control. So when we put it all together, what's the takeaway? Flywheels are our mechanical batteries. They tame the violent power of engines so we can have smooth motion. They let small, efficient motors save up energy to do massive jobs. Honestly, from the car you drive to the factories that build our world, they are absolutely essential. You know, the flywheel is just a perfect example of a simple, elegant idea that solves a huge problem. It really makes you wonder, what other simple mechanical marvels are out there quietly working behind the scenes?